Hello and welcome to our channel Artezmia. This episode is not directly about electronics, but it's still related to it, as we will show how to install the ESP-IDF on a Linux computer with a Debian-based distribution. I haven't used a Windows computer for about 15 years, and that was Windows XP at the time, so I have no idea how this works on a Windows computer. I just know it is possible and it works. I have also no idea about Mac computers. The motivation behind this video is that I first wanted to use ESP-IDF within VS Code and Platform IO. Unfortunately, there were too many warnings popping up and too many issues arising, requiring to waste a lot of time researching for solution. Of course, the C editor is very nice, and it is very nice to be able to build a project and upload it at the push of a button. But that does not compensate the numerous issues to be resolved with every project. And if you upgrade it to Arduino 2.0, you will see you have to modify all of your old codes for them to build. I also think that if you're able to copy some code and paste it to your project, knowing what you're doing, you might as well go one step further and write better code in an environment that was designed for the ESP boards. In this video, I will show the window in which I send the commands. The machine answers will be different if you try to do it yourself, because all the process has already been done on my computer. So machine messages will be of the kind such and such a function is already installed and is of the latest version. In the description below, I will list all the commands to be entered. Let's get started. First, you have to make sure your user is member of the sudo group. First, we have to update the database of packages installed on the computer. Now we have to upgrade to the latest distribution and packages available. Okay, since everything was up to date, there was nothing to be done. Then you have to install a few packages. Okay, as I said before, all the packages have already been installed and they are up to date. If you have a subdirectory called ESP-IDF, it means that you already have an installation of the IDF. This is my case. I have version 4.3.3 installed, and I will install version 5.0 that came out less than 2 weeks ago. For this, I need to delete the ESP-IDF subdirectory. If you do it with the command line remove rm-r ESP-IDF, it will ask you for all subdirectories if you want to delete them because they're write protected. So the simplest method is just to go to your file manager and delete the subdirectory. Okay, so here we're going to clone the GitHub of Espressif for the IDF, and it will take a little bit of time, but there we go. I probably will compress the parts where the installation is being done. Okay, there we go. It was not too long. Okay, now we will have to install the boards that we will be using. So for this, we'll go to the ESP-IDF subdirectory. We first install the ESP32 board. Then we install the ESP32S2. The ESP32C3. And you could install the ESP32S3, the C2, and the H2 that are supported by the new ESP-IDF, except that I don't have any of those, so I'm not going to install these. I'm not going to install these. Okay, now you have to install the tools. Okay, now it says we can run export, the export shell script. Now your terminal window is unable to run the ESP-IDF. If you open another window, it won't be enabled unless you run the export shell script again. You might want to add the shell script, the export one, to your .profile file, unless you. But if you do that, every terminal window that you open will be enabled, and that would eventually add up using some of your memory. You may think about it. Now let's start a project. I will open a new terminal window and enable it to run the ESP-IDF. If you wish to try the examples, use the examples from the ESP/ESP-IDF/example subdirectory rather than search the web for examples. Version 5.0 is a major upgrade from the previous versions 4.3.3 and not exactly backward compatible. Not all code written with previous versions will work with 5.0. I will try my different boards with the same sketch that connects to Wi-Fi with a fixed IP and flashes pseudo-randomly 2 LEDs on a breadboard. The code is available on one of my web pages as described in the comments below. You first have to specify for which class of board you are building the project. C3, C3 Mini, C3 Pico all classify as C3, for example. S2 Mini classifies as S2. ESP32, W-Room, W-Rover, and all flavors classify as ESP32. In the ESP folder, I created a subdirectory named OneTest, and then I created subdirectories named C3 Mini, C3 Pico, S2 Mini, W-Room 32, one for each board that I will test. In each of these folders, I copied the folder static underlined IP from the ESP/ESP-IDF/examples/protocols folder from the installation. Then in each of these folders successively, I go to the main subdirectory and rename the static IP example main.c simply main.c, and I edit the cmakelists.txt file to reflect the change. There are a few things we have to add to our main.c file as opposed to the example of the static IP. Anything that has to do with GPIO. So first is the include instruction that's on line 25 and the instruction that's on line 27. The latter one is something that's been introduced in IDF 5.0, and if you used a previous version of the IDF, you won't have that need. Normally, this include rom/gpio.h should go inside the driver/gpio.h, except that if you reinstall your IDF or if you update it, then it will disappear and you will have to do that again. In my view, it is better to include this instruction in every file that you write. Now, this is only if you're going to use GPIO. The other thing that's specific to our example is the task functions. The code that is line 210 and the following lines is to define two tasks to get two LEDs to flash pseudo-randomly independent of one another. So we define the GPIO pin number depending on the board. So 6 and 7 are for the C3 Mini and C3 Pico. For the S2 Mini, we go with pins 18 and 35. And I don't remember offhand what's for the W room 32. And then we go to the app main. First, we call the tasks to flash the LEDs, and then we connect to the Wi-Fi access point.